Hi everyone, and welcome to part 2 of Pre-Calculus Lesson 7.1, Trig Identities. The next part of our lesson is about proving trig identities. So again, we're going to start with some strategies. The goal is to try and transform one side of the equation into the other side using any of our trig identities. So you pick one side of the equation, and it's always easiest to go to the complicated side. I know that seems counterintuitive, but there's more that you can do there. So pick the complicated side of the equation. Then you're going to use your identities to simplify that side, just like we did in video 1. You can convert to cosines and sines if you get stuck, but the goal at the end is to make the side that you picked look like the other side. Now, if you get stuck, start playing with the other side. But it's really important to remember you are never allowed to add something to both sides of the equation. You cannot cross that equal sign. Consider them almost like two separate questions. You can't subtract sign on both sides of this. You can't divide both sides by cosine. It's not allowed. You cannot treat this like an equation because we're trying to prove it. We don't know if it's true. So you cannot cross the equal sign. So what I've done is I've put an example on the screen. I recommend pausing the video and try to decide which side is the more complicated side, and then try to simplify it and see if you can get that side to look like the other side. Then hit play and I'll explain the way through it. I decided that the more complicated side is the side that says cosine theta is multiplied by secant theta minus cosine, so this side. Now there are lots of different ways you can do this next part. So if you didn't do what I'm doing, that's okay. I decided to simplify this by distributing. I distributed cosine into the parentheses, and I got cosine theta times secant theta minus cosine squared theta. Okay, now I'm going to see if I can simplify the cosine theta and secant theta. I decided that secant theta has a reciprocal identity. So secant theta is the same thing as 1 over cosine theta. And cosine theta times 1 over cosine theta is just 1. So that expression right there turns into 1. And I'm left with 1 minus cosine squared theta. Now, if you remember in video 1, I recommended that anytime you see a squared trig function, that you think about the Pythagorean identities. This particular one reminds me of this very first Pythagorean identity. Now, it's not exactly the same as it, but I can change this Pythagorean identity into this just by subtracting cosine on both sides. And you are allowed to do that because these have been proven. So I know that sine squared equals 1 minus cosine squared. And I'm allowed to do that. So that's going to be my next step. So I can replace 1 minus cosine squared with sine squared. So what that gets me is this whole side of the equation is the same thing as sine squared. So I have sine squared equals sine squared. And I just replaced this with the sine squared that I just got, and I kept what it was equal to on this side. And I've proven this identity because I changed this first side into the same thing as the second side. And that's how this works. So let's look at another example. The next example I picked is this one. It says to verify the identity 1 plus cosine theta over cosine theta equals tangent squared theta over secant theta. So again, I recommend pausing the video, trying it. Try anything you want to try. Remember, keep that eraser close. I always have a big eraser next to me when I do these, and try it. I decided to start on the left side of the equation, 1 plus cosine theta over cosine theta. Now, it doesn't seem like there's a lot you can do with that, but I decided to split it into two separate fractions because it looks like the cosines can, cancel out. So I did 1 over cosine plus cosine over cosine equals secant plus 1, because this is a reciprocal identity with secant, and this is equal to 1. And that's about all I can do on that side of the equation. And notice that that does not look like this. I can't think of anything else to do though. So what I'm going to do is I'm going to look at the other side of the equation. Now again, notice I'm not going to try and subtract 1 to this side or anything like that, but I can say that this is the simplified version of this side. Now I can play with the other side and try and get it to look like what I just got. So I'm going to look at that side next. What I did is I saw a tangent squared here. That reminded me of a Pythagorean identity. Tangent squared plus 1 equals secant squared. And I can subtract that 1 to this side to find out what tangent squared is equal to. So tangent squared can be replaced with secant squared theta minus 1. Now, secant squared theta minus 1 is actually a difference of two squares. This is a secant squared, and this is a 1 squared. So I can factor that, and that's why I picked this particular question, because I wanted you to try the factoring. So secant theta minus 1 times secant theta plus 1 is equal to this. It's a difference of two squares. Then I can reduce my secants. And that's what gave me the big idea, is that I knew I had a secant minus 1 down here. Now I can't just reduce this. I can't just cross out the 1s and cross out the secants and just get secant, because there's subtraction happening in both of these. So you can't reduce it as it is. But if I get this to a factored form, then I can reduce secant theta minus 1 and secant theta minus 1. Those can reduce, and I'm just left with secant theta plus 1. And that's exactly what I had for the other side of my equation. So I can say, yes, it is an identity, because I got the same expression for both sides. Now we just have one more topic to talk about. That topic is trigonometric substitution, and it sounds really scary, but it's exactly what we've been working on for this entire lesson. What I do is I take a trig function and put it into an algebra expression, and then I simplify it. So in this example, it says to substitute sine theta for x in the expression. So I'm going to take sine theta and plug it in for x. Then I just have to simplify what's there. So let me show you what I get. When I substitute it in, I get the square root of 1 minus sine squared theta. Now 1 minus sine squared theta reminds me again of a Pythagorean identity. And actually, if I solved this for cosine, I would get the square root of 1 minus sine squared theta, because I would subtract the sine squared to this side, and then I'd do the square root to get cosine alone. So this expression is just equal to cosine. So my final answer for this example is just cosine theta. Now, I know this is really hard, but the more you practice it, the easier it gets. Remember the strategies I've said, and remember what you know about algebra and what you know about fractions. So keep practicing and let me know how I can help you.